I'd like to start by thanking you for hanging around. It's been a very long day. At least there's more of you than me. Anyway, I forgot to actually put my name on this, but I'm Lisa Urquhart. I'm the editor of EP Vantage. I run a news comment analysis service on the healthcare and biotech industries. So I'd like to start by thanking you for choosing this particular session. And as you can see from the title, we're going to be taking a very broad, at this point, very quick overview of the pharma and biotech sectors to identify growth opportunities. But firstly, I'd like to warn you that biotech and healthcare investing is not for the faint-hearted. Stocks that can rise 80% one day on the back of good news can also fall just as fast on the next day due to bad clinical trials. So just an example of what just an example of some of the rewards can be, I've got three different stock charts here. The first one is the NASDAQ biotech industry. So as you can see, that between January 2013 and September 2015, it rose 136%. And that compares with 1% for the FTSE in the same period, and a slightly more respectable performance from the Standard & Poor's 500. But I like to think of biotech as being a little bit like a teenage relationship, where there's big highs and also very big lows. So in the period between September 2015 and March 2016, the NASDAQ has lost 20%, almost 20% of its value, whereas you can see the other two indices have actually gained. So does this mean, actually, one of the things I should want to do is talk about how small events can influence healthcare stocks. I don't know if any of you remember the Hillary Clinton's tweet, or if you know anything about it. Back in September, there was reports of how some pharma companies had been jacking up the prices of very old drugs. At that point, Hillary Clinton picked up her phone and started making comments about how she would personally tackle what's known as price gouging. That was enough to wipe billions off certain healthcare stocks. So it's just another example of just how volatile and how other sentiment can really affect pharma stocks. But does that mean that it's not a particularly attractive sector? No. Despite short-term volatility, you can see from this chart that the industry is expected to grow between 2015 and 2020 by over 6%. So that means I do think, so while there is, as I said, there are short-term volatility, long-term I think it remains a particularly good defensive stock. So what do we think, what might be behind the 6% rise that analysts are predicting for the sector? Well, there are a number of factors, some of them I'm sure you might be able to guess. I think the biggest one is the ageing population. We're all living longer, which means we're all at risk for diseases of the elderly, which include cancer, dementia, eye problems, and also if we're not getting any younger, globally, we're not getting any thinner. So another thing that I haven't put on the list is the fact that obesity drugs are also going to be driving a lot of this growth too. And then we've also got emerging markets. As nations get richer, they spend more on healthcare. And that also includes governments, not just individuals. And then we've also got improved R&D productivity. So regulators are working a lot harder these days to get new and innovative medicines to patients a lot quicker. And then we've also got excitement around new products. I don't know if any of you are Daily Mail readers, but pretty much every other week there is a new cure for cancer. As to how many of these actually pan out over the years, who knows? But there are some interesting, there have recently been some interesting and particularly exciting developments, including checkpoint inhibitors, which mean that some melanomas are practically people in stage 4 cancers are actually seeing remissions. We've also got the CAR-T therapies, which are using people's own immune system to fight cancer. So while that's very early stage, it's still very exciting and people think it could drive the industry. And the other thing that I will be coming back to later in my talk is biosimilars. These are sort of copycat versions of biotechnology drugs. I'm sure most of you have heard of generic drugs, which are versions of small molecule drugs, where biosimilars are similar drugs to some of the big cancer drugs, like Herceptin or Avastin. So let's have a slightly sort of more in-depth look at some of the actual therapy areas. Apologies. Almost a free laptop for me. Driving some of the biggest areas of growth. I mean, this is quite a confusing chart, but anything basically in the lower left quadrant isn't a good space to be in. So it also showed growth, future growth, and also past growth. So as you can see, the bottom left-hand corner is genitourinary, which is basically, it's a low-growth sector. It's characterised by things like hormonal treatments, mainly sort of testosterone replacement gels, fertility clinics, and it's not particularly exciting. And the few exciting drugs we've had in there, like Viagra, have actually now lost patent protection. But I mean, I can pick out a few other things that I think will be driving the industry. So we've got systemic anti-infectives. That includes antibiotics. I'm sure you've all heard about antibiotic resistance and what a big problem that's going to be. The problem we have with development in that area is the fact if somebody did come up tomorrow with a fantastic antibiotic that could solve antibiotic resistance, nobody would actually use it. It would be the drug of last resort. It'd be behind a glass cabinet with bars in front of it with a big do not break glass only in case of dire emergency. So it's a big area, lots of people are working on it, but until we figure out a way for paying fairly for antibiotics, I don't think it's going to move that way towards the right. We've also got sensory organs. That includes, once again, eyes, which is old people, but a friend of mine reckons that because of the use of iPods and personal devices, we might have a huge uplift in hearing aids, particularly with teenagers as they get older. But I think the biggest one there is, well, we've also got CNS. The two I'm going to focus on next are CNS and immuno-oncology. CNS is interesting because it's still towards the low end of growth. And that is because we find it difficult to develop drugs in this area. But if we could come up with a decent disease-modifying treatment for Alzheimer's or dementia, that red bubble would be somewhere, I think, across the river in that way. We've also got immuno-oncology, as I said, cancer treatments, which, as we all know, the ageing population and also the fact that we're understanding the disease slightly better means that that is going to be one of the industry's biggest growth areas. So, as I said, I was going to look at the two areas slightly more in depth, and we can see some of the biggest drugs that are currently in development in CNS and cancer. The other reason I think people find it difficult to invest in biotech is because they name the drugs names that are almost impossible to pronounce, which I think puts investors off. So I'm going to give one of them a stab. I've actually written it down phonetically. So the first one, the one with the biggest growth, with 20 billion, is atezolizumab, which is a multiple sclerosis drug. So once again, it's trying to hit one of those sweet spots in CNS, difficult disease area, where we see multiple drug failures. Underneath that is a crystal of, I can't actually see that actually. Ocrelizumab, which is a cancer drug, a lung cancer drug. Because there are so few effective treatments in lung cancer, that's why it also has a massive valuation attached to it. So as you see, Roche, potentially a good company to be looking at if you're thinking about investing, because it has products that are worth almost $30 billion, according to the analysts. But despite some of the big CNS things, cancer is going to be the industry's biggest growth driver. Okay, but as this is an investment conference, I thought I'd also include some smaller companies that don't have partnered assets. These are companies are looking for other companies, bigger companies, to help develop their drugs for them. So meaning if they did find a bigger pharma company to help them develop these drugs, there will be some upside. And you can see the difference, I think what's interesting here, between the market cap of some of these companies and the actual NPV of their products. While some of the NPV, I think, forecasts maybe a little bit of analyst exuberance, it does see the potential that some of these drugs have if they are successful, and how they can potentially massively lift the market cap of the companies that are developing them. So one of the things I talked about earlier was biosimilars. And as I said, they're copies of biological drugs. They're not exactly the same. That's why they're called similars. I think that's what people get confused about generic drugs and biosimilars. So I think there are more biosimilars out there than people expect. So we've got 117 products in clinical trials. They have 20 on the market in Europe already, and they're being heavily substituted in Europe. Not so much in the US. The US has been very slow to actually find a pathway to approve these drugs. Part of it is safety concerns. The other part, I think, is quite a heavy lobbying on the part of pharma companies that with vested interests of originated drugs. But we've had 3 approvals so far. 2 of them have been in slightly less exciting areas of insulin, but we've had 1 drug, Zarzio, which is a blood replacement product, and we could see other cancer drugs coming to the US soon. So that's what I'm saying, more complex drugs are now being approved as opposed to the growth hormones and the blood replacement drugs we've seen. In Europe, where we have most experience of biosimilars, the discounts you're getting to prices are typically between 30 and 40%. Normally with small molecule generics, these are 90%, up to 90% discounts. So while they're cheaper than small molecule generics, they're still a little bit more expensive. But I think Norway is showing the way by actually, the government has basically negotiated the price for Remicade, which is a biosimilar, Remsima, which is a biosimilar version of Remicade, which is now being sold at 79% discount for the originator. And that is because the Norwegian government will only buy this product. So I think in Europe, if healthcare agencies and governments do actually put their foot down, then we could see substantial discounts for some of these biosimilar drugs. And just in case you want to see what the predictions are, this is predictions from my parent company, Evaluate Pharma, saying how much we think the biosimilar drugs could take off. So you see a very low base in 2010, going up to almost $5 billion, or $4.5 billion by 2020. But that could be even bigger. We have companies like Express Scripts, which are pharmacy benefit managers in the US, arguing to get their costs down. So they were saying that they reckon if they could save $250 billion between 2015 and 2024 if just 11 biosimilars entered the US market. And I think we're going to see pharmacy benefit managers and payers becoming more vocal about the drugs that are used on their formularies and used by patients. So, who's going to lose in the biosimilar race? So these are some of the, obviously, the bigger companies. AbbVie is particularly at risk. It has, it derives almost over 60% of its revenues from a drug called Humira. There biosimilar competitions coming for that one in the US. Sanofi, it has a very large diabetes franchise, including its long-acting insulin called Lantus, and there are already biosimilar versions of that coming. Merck and J&J, they have a drug called Remicade, which has already seen generic competition in Europe. And Amgen, once again with its blood products, is also seeing has most to lose from biosimilar competition. But then again, so conversely, who are going to be the winners? So it's quite an interesting and unusual bunch, not some of the people you'd expect. While some pharma companies are actually getting on the act and trying to protect their own franchise by sneakily producing biosimilars of their rivals' products, you've got some very small, interesting companies like Celltrion. They are a South Korean company. They've got, in development, they've got biosimilar products for Humira and also, once again, Remicade. And interestingly, you've got LG Life Sciences. I mean, most of us associate LG with, electrical goods and whatever, but once again, another Korean company getting on the act, and we're seeing more and more Korean companies actually because of the life science industries there, particularly with stem cell research in that region that's quite hot, coming into this space. So LG have obviously seen an opportunity, and they are trying to develop their own products, biosimilar products. And as I said, once again, Pfizer, it's a bit like a game to keep a term poacher, isn't it, really? So while some of their products are at risk, why not go after other people's products? So I think we're going to see more of that. So you have these interesting sort of legal battles about patents, with some of the companies arguing that, the upstarts like Celltrion are infringing their patents, yet meanwhile in their own laboratories they're trying to infringe other people's patents. So we spoke about some of that, but I'm doing this very quickly because I know we're running over. So we've seen some of the sort of knowns, but I thought I'd put on this some other less clear things I think that are going to be happening to the industry. So one of them is convergence. So last talk was about medtech. We've seen more and more convergence between healthcare and medtech, and also technology. I mean, I think one of an interesting example is the fact that Novartis is developing a contact lens alongside Google to a smart contact lens actually monitors your glucose levels. So this contact lens, it looks a bit strange, it sends information about your glucose levels to a computer that can be monitored. Google itself now has a healthcare division called Calico. They've signed an agreement with AbbVie, and they're looking at diseases of aging. And the CEO of Calico has very famously said, you know, somewhere in this room is the next person that's going to live to 200. I'm not sure if I actually want to, but they're looking at that anyway. So I think we're going to see more and more of that. And so I think the idea of is that healthcare is going to become a misnomer. It's going to be healthcare solutions maybe. Then we've got digital health, which is I think I would have been wearing my Fitbit today if I'd remembered to put it on. But it's also about the amplification of health. We're all very much more interested in monitoring our health, so whether we've got Fitbit or something else. But I think it's getting more interesting in the fact that it's going a little bit further than I think the FDA has approved an app that does remote monitoring of pacemakers. So while some of these things are just kind of sort of health, sort of personal health related, the FDA is actually taking this very seriously and actually wants to standardise some of these measures, because some of the health claims around some of the apps I think have been a little bit spurious. So the FDA is finally looking at this and actually saying this is setting out standards for the digital health. And along with the amplification and digital health comes IT and digital security. I know you've all heard about the Internet of Things, where your fridge can have a look inside and then go to Tesco's and order you, or Waitrose, depending where you shop, and order you more stuff. So, but then again, somebody could ideally hack into your fridge, turn it off and ruin everything inside it. So there are also fears about people being able to hack your pacemaker, which I think is slightly more worrying than coming home to some soggy letters. So I think there are opportunities in the healthcare sector for people to actually become around this idea of digital security. So it's another area to watch. And the other one is, I think, pay performance. It sounds counterintuitive that if a drug works well, you should get paid more for it. But at the moment, we just approve drugs, and it seems like this is me saying this, by the way, it seems like the pricing structure is what they think the market can bear. So, but I think we are now seeing payers, once again, people like Express Scripts, Walgreens, and CMS saying that actually, we want to see, if we're paying for this drug, we want to see what the outcomes are beyond, a small clinical trial that may have only had 10,000 people at tops in it. So recently, I think last year, we saw a group called Harvard Pilgrim Healthcare. They're a small health benefits manager, but they did a deal with a company called Amgen, saying that they would pay more if Amgen's lipid lowering drug, cholesterol lowering drug, actually had really good outcomes as they measured it, or if patients took it more. So I think that is the way the industry should be moving towards. So we actually have clear outcomes for what you're actually paying for. And also Express Scripts, once again, one of the most vocal payers, they are actually looking at payment for indications. Like, for instance, I don't know if any of you know a drug called Avastin. It's a cancer drug that has multiple applications, from colorectal cancer all the way through to breast cancer. It's more effective in some of the indications that it's approved in. I mean, it's not very good in breast cancer, but it's approved there. But as payers, you pay exactly the same amount for that drug, despite its efficacy. So what they're thinking about doing is actually doing payments. They want to force through payments by basically indication. So if it works better in one indication, you get more for it. If it works less well, you get less. And so what does that mean? That means it's about big data. I don't know about the rest of you, but my favourite quote about big data is, let me read this out, it's like team sex. Everyone talks about it, nobody really knows how to do it. Everyone thinks everyone else is doing it, so everybody claims they're doing it. So, but we will need to process, if we are going to go pay for performance, we will need to process a lot of data, a lot of patient data and records. As to how we do that, I don't know, but I think some of the analytic companies, like the Googles of this world, and they will be the ones perhaps maybe driving this, because they do have that experience of crunching large amounts of data to make sure whatever ad you've been looking at pops at your Google search. So I think real world data is coming. There are people outside of the industry that mostly do it better, and I think people within healthcare might want to buddy up with them sometime soon. That's pretty much the end of my talk. So in conclusion, as I said at the beginning, healthcare is not for the faint-hearted. The risk reward profiles are quite great, but if you you do your homework, you look at the trends and you spread your risk, it can be very rewarding. Thank you. Any questions? I think we're back on time now. 10 foot at the front.
about biosimilars in Korean companies. So in the mobile phone world,
Yeah.
Samsung, for
Samsung,
example.
very active in healthcare as well.
Everybody went ahead, sold the products. Sell now, Sumi, will resolve it many years later, and I got revenue in. Is that the same model for biosimilars, or are people not going to put things on the market prior to any legal issues being behind that?
Well, if you launch at risk and you get it wrong, you then have to pay the company whose products you've infringed.
Yeah.
You have to pay them back vast amounts of all the money that you've accumulated in the sales and any other costs incurred. So it could cost you. So most people don't launch at risk. If you do, you tend to do it with something less risky, like a small molecule drug that maybe other people have got. So it's very unusual to actually launch at risk in the biotech world because the financial penalties.
So they're materially different from, say, a mobile
Yeah,
phone.
absolutely. Yeah.
And
You also have periods of exclusivity as well.
Sorry?
You also have periods of exclusivity. So if you want to launch a biosimilar drug, if you get approval, the person that originates the drug still has a 180-day exclusion period where they can still carry on selling that product till before you can start selling your product. So you get 6 months, even if somebody infringes your patent and then gets it approved, you still have, as the originator, 6 months of being able to sell from that point. It's because I think the difference with biotech and mobile phone industries is the development times. It's going to take you 10 years to develop a drug. You're going to want to hang on to those sales for as long as possible. Any other questions? Well, thank you for your time and attention. I said it's been a very long day, and I hope it was worth hanging around for.